Before, to represent the world of energy, all we needed was to draw a pyramid. At the top, large power plants which generate electricity. Below, high voltage power lines, then medium voltage power lines, and then low voltage ones. Distributing electricity to houses and apartment buildings was simple, but that was before. Since then, power production can be much more distributed. Thanks to new technologies and the development of renewable energies, it's all mixed together. Roles cross over and swap over. Everything has become interdependent. And this is just the start of the revolution. Good news, you may say. Yes. But when energy flowed from top to bottom, it was pretty easy to see the logic between production and consumption. Now the energy flow is much more complex, since power can be produced everywhere, and to prevent anarchy, the rules of the game have to be reinvented. How can we make the energy flow, the electrons in the network, as fluidly as possible? How can we optimize production, consumption, and the related expenditure for the entire system while saving energy and keeping our systems in line with sustainable development? Imagine we look at a given home with several pieces of equipment producing and using energy. Let's imagine, for instance, a fridge, a vacuum cleaner, a washing machine, a solar panel, and a battery in a home. To make the system work better, we would need first to look at each appliance and be able to analyze its power demand in real time, depending on its consumption. Or analyze the outflow of electrons from it in real time for equipment that is producing or storing energy. One appliance operates 24/7, 365 days a year. Another operates a few times a week, and another every day after 10:30 p.m. This changes everything. As for the solar panel, it produces energy from time to time when the sun shines. It's really not easy to control the electron traffic in these conditions. Now, let's imagine that all those devices are able to talk to each other in order to organize the flow of electrons between them in the best possible way, in a safe way, taking into account the physical and security constraints they have, respecting the private life of their owners by securing the data they exchange. And what if, in addition, we manage to tell them how outside factors will impact them, like how their power consumption and production will vary if there is snow falling, or a hot spell, or cheap energy on the network due to sudden wind blowing? Well, all of it is possible with the SEAS project. SEAS means Smart Energy Aware System. In other words, we bring a common language and intelligence to all these pieces of equipment. At noon on a Sunday, the sun is shining. My solar panels are generating more electricity than I need right now. Shouldn't I store my electricity? Or send it back to the grid? Thanks to SEAS, devices share information intelligently with one another. They will know that the sun is shining and will direct power from the solar panels automatically to the equipment that needs it. The piloting also takes into account my usual needs, and by a given hour, the power is automatically being channeled to the battery. Now, let's imagine all homes have SEAS inside pieces of equipment that talk to each other. They will know when the sun shines, there's no point in sending my solar electricity on the grid because others have enough. But the system will also know that the excessive energy produced by my solar panels today will be useful to recharge my neighbor's electric car in the night, and it will transfer the electrons automatically at midnight. So what do we need to do all that? A common language, as we have seen, but also the connection of objects and systems. It's the Internet of Things. And the SEAS project is trying many different Internet of Things systems to test all the new technologies available in different countries over Europe, and a secure data lake. And the SEAS team is working with the help of lawyers and data experts, including cybersecurity experts, on solutions to store data safely. Welcome to a greener world that is centralized and decentralized at the same time, where all equipment using and producing energy communicates, a world that works as a community and is optimized. The energy world of tomorrow.